Hi!
Hey!
It's me again, Maxim Vuyet, and tonight we're going to talk about iterators. And this is my third talk in a row at Amsterdam XPM, so I have a streak.
Such kittens!
And someone, Email Ray, gave me feedback about one of my last talks, saying like, you know, it was okay, but you had too few kittens, so we will have a lot of kittens tonight. Iterators, what they are. But before we can discuss this topic, let's imagine that you are a cat, right? And if you're a cat, you are usually hungry or angry. And you have to search the house for food. You need to like peek into the kitchen, like check all the cupboards and drawers, and like open some cans. It's obnoxious. So the problem is too much stuff to sort out. You like need to access all this data, know about like how all these drawers work, how to open a can. It's too much work for just a cat who wants to eat, right? So it's kind of cat. You are lazy. You want just have food. So this is what you would prefer, right? You just have your box and you take food. So this is where iterators come in handy. Iterators
Yield food from cat.
it's like a way to abstract all these complexities of accessing all the source of food, and you just like have one method, and you just give me food, right? Good. So now boring slide. You all know about iterators already. You use them every day. Like there is a shitload of iterators in Perl built in already, but they kind of like all have not very uniform interface. So you iterate over a file handle. You don't give any. You don't care like how you access the disk and position the head if you're still like running all these disk drives. You just give me the line, right? You don't want to know all the details underneath. Rigdir, another one, when you want to iterate over all the files in the directory. DBI. Who knows how all these databases work? You just want all the records. And you like call fetch, and give the data, get the data. Another one, very tricky, itch, that allows you to iterate over a hash and getting pairs of keys and values out of it. Try to not use it because hash contains an like internal iterator inside itself, and you can screw up really badly. I did once. I know what I'm saying. Regular expressions. That flag G, you can like iterate over all comments in the file, like using the regget, something like that, right? So it memorizes the place in the string where was the last match, and next time you call it, it continues from that position. And the pseudo number generator is also kind of an iterator because it maintains a state, and every time you use it, it uses the state to generate the next number. And if you start from the same state, you always guarantee to get the same set of numbers. If it's a pseudo random number generator. So, but before we go next, let's talk about something else cool. And another super cool concept is closures. Closures are these anonymous subs that retain the state or environment in which they were created, right? A very, very simple example. We'll start simple. Just anonymous sub. We create a sub, meow, and we call it, and it meows, right? Now let's make a closure, such as it actually retains some state. So we make a function that creates functions. We make utterer. We give it an argument, what utter it should produce. It takes that argument, it retains it, and then returns a sub, say sound. So that actually, when we call that sub, it like kind of have a link to the sound scalar, so it has this data. And when you call the function that function generated, it actually pours. Very nice. Closers, that's so cool. let's use them for some good, right? And actually, combining iterators using closures to make iterators. This is how we can do this. Very pretty simple example. We make another iterer that has a local list of sounds a cat may produce, or I mean, and every time we call it, because this list is now kind of like local, encapsulated, closed for the closure we just generated. Every time we will be calling it, it will be returning each next single element from the list. And if we create multiple iterers using this function, they all will be independent. So, and like you can exhaust them individually, and they will return all these 4 words until you exhaust it. Good. Now, that was pretty simple. Now let's do something more fancy and smart. And by smart, of course, I mean what? Fibonacci. But Fibonacci, like classy, boring, we will make them cat flavored, right? So the same idea. We generate a function. You see, returns up. That just maintains 2 last elements. Every time we sum them, throw one away, add another one, you know all this stuff. But instead of returning a number, we meow number of times as the Fibonacci number represents. What's interesting about this example is that this iterator will be actually infinite. So don't call it in the while loop, because it will just basically run till it runs out of memory. So we like if we want to take first 10 elements, let's go do it. And this brings us to the point that this one was actually lazy because it doesn't compute all the elements of the Fibonacci list upfront, but upon demand. Like every time you ask it, it's like, oh, hi, stand up, generate the element. Now, let's, out of all this theoretical examples, make something more sophisticated and like closer to the real world. And we will start with a trivial, simple example and try to make it more complex and sophisticated over time. So, another boring slide with code. What we do this here is, we have a file, food.txt. We want to process it somehow, mangle, and then have some hope. What we do, we open it, we read the entire file into memory, into the list food. So we have data. Next step, we iterate over the array, options, and like do something simple. Like maybe our kitten is lazy and doesn't really want to deal with food. What name is longer than 8 characters, right? So we skip those records. Then we process them somehow. So we make an option out of that item. We make it super option, meow, and push it to the array. So we basically process data. We filter out something, we process it, and we store it. And then we open a file and basically dump all the records to the file. Pretty simple, huh? That's how we usually do it. But it has a couple of pros and cons. Pros, it's easy to write, it runs fast, and the main point is that constructs are separated. So like getting the data, processing data, and outputting the data is all separate. And we can easily hack on all these aspects separate. The disadvantage is though, it's memory bound. Like, if the file is too big, it just simply doesn't fit into memory, right? So, what we can do is try to process the file as we go. So we open both files at the same time, we iterate over each line, and do the same processing, right? We skip it, we mangle it, and at the end we output that line to the file, and then close everything. Good. But now we have constant memory. We can process as big files as we want. Performance stays the same. Disadvantages. The constraints are now mixed up, so we like opening the file, reading the file, processing the file, outputting somewhere. It's all like mixed up in one this enormous loop. Well, not enormous in this case, but you can imagine the real world scenario. And it's kind of troublesome to maintain. So code reminds us like of some noodles code, right? That brings us to the next stage, when we actually may use iterators to simplify this code. And at glance, this is like all the code that we have looks very simple. We have some function reader that takes a file name and creates an iterator out of it. Then we have a couple of magic functions: imap, igrep, iterative map, and iterative grep that can work with that type of iterator. And then we have a writer that takes the iterator and dumps it into the file. And now let's look at each of these pieces and separate. So the reader is pretty simple. We open a file and we return a closure. So closure has an access to the file handle that we're iterating over. It reads the line, chunks it. If the line is defined, I think I found the file. Moving on. If the file handle is exhausted, if there is nothing to return anymore, it's on depth, then we just close the file handle and return it. Otherwise, we return this line we just read, right? And every time we will be calling this up, it will be returning as just one element. It's basically the same iterator, just wrapped in a nice unified interface. igrep takes a callback, which will be the predicate that evaluates whether the given element should be skipped or passed on. And it returns another iterator that wraps the given iterator. Returns a closure. In a while, it calls the iterator, that's the source of data. It returns the data. It checks if the data, according to the callback, is a predicate, should be passed on or not, and returns it on. And then returns on depth to indicate the iterator is exhausted. IMAP, pretty simple, pretty similar. We get the next value out of the iterator. We check if it's exhausted or not, and we just call that callback, pass it on to transform the data. The writer opens a file, takes the source of data iterator, iterates over it, outputs the file. So again, the same example. We take an iterator, we pass it to the graph, we check the length of the string. All that passes this criteria gets passed onto the iterative map, which does something else with the string and returns another iterator to grab this. And then the writer will be actually consuming all the data. So until this point, where at this point, that file is never opened. While it's open, it's never read. Because it will be read only when we actually start consuming data out of it. So all control flow is actually focused in the consumer part. Advantages. So concerns are again separated. We have some abstract writers, readers. We have a nice routine that can process the data hidden behind the iterators. We have again constant memory. The code is flexible because we can pile up and stack all these different maps, grabs, or some other code to work with iterators any way we want. And it's lazy. It's so lazy because we won't read anything, to process anything to the very, 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 very end point when they actually hey, I really need some data now. Right? And this is pretty much it. If you're interested in the topic, I definitely recommend this book. Everyone recommends. It's difficult. It took me a while to actually read it. You don't have to read it from beginning to the end. It's more like a reference, but definitely worth checking out. And this is it.
Forgot to add that Larry said laziness was a virtue. When you had your pros, you said it's lazy, and Larry Walsh said that it was a virtue. So
if we can find a photo of Larry in a cat suit.
you should have Larry next to a cat, or turn the page into cats.
Yeah, it's always Photoshop.
Yeah.
Challenge accepted.
I take it your word. Any questions?
What is your Dogecoin address? It's not on the slide.
There we are.
Is there a package that implements all these nice functions?
Great question. So, yeah, there is one, I cannot remember. But the point is...
That's a big part of the question.
Yeah, thanks for reminding me. the concept of iterators are that you don't like have a library of iterators or something. It's like a pattern, speaking in terms of Java enterprise world. It's like a way to organize the code. It's not a function that like just does something for you.
But what good that pattern is if you have to write graph every time?
So like the basic things, like I reduce, map, grep, they exist. Just cannot remember the package, and I'm sure there are quite a few out there on the sequence.
Do they follow the same iterator interface?
Yeah. Well, I guess, yeah. I actually wrote, so I worked for Booking, and one of the very first modules that I wrote was iterator. And all it does is, it takes coderef and wraps it in an object-oriented interface, so it has a single method next that calls that coderef. So it does nothing, just fancy syntax sugar.
Oh, wait, it only has next method, does it also have an interrupt method? Because you gotta be able to say, hey, I'm done, no more nexts. That's usually
I guess
also.
you can leave it all up to the garbage collector.
Oh.
We deal with high level stuff, we don't like care of the garbage. Cool. Anything else?
Yeah, and yeah, please. Yeah, and in every your function like igrep and imap, you check if the previous is undefined.
Yeah.
Can you abstract it away so it's out of that functions? So you can make a sequence of functions, and when the one returns undef, you just don't continue.
Sounds like mods.
Yes, it's maybe monads.
I don't know.
I mean, you can do maybe monad in the term and this sequence.
Sounds very important, so yeah. No, I don't know. I need to like understand
already have-
what you mean by that.
Yeah, we already have monads, maybe monads in Perl. No, I mean, we use
Does
it.
anybody else know?
Okay.
I mean, anybody else know the answer to the question? Sorry,
I can show you.
he was the second.
Mostly the same thing. What if you have a list with undefs?
Louder.
What if you had a list or a set of data that had undefs in it? You were using undef as your marker.
Fair point. And this is another reason why you don't usually want to use some existing implementations, because it really depends on your case. So in my case, I knew for sure that I won't be able to read undef from a file, so I use it as an indication of the end of the stream. What you could do also, you can always wrap the argument in some sort of array ref or hash ref. Then when it's undef, so undef will be packed inside the hash ref, like item or some auxiliary data around it. Or another way that people may do is return two elements. The first one will be the data you're interested in, and the next one will go a flag, like if there is still anything else in the stream or not, if that's the last element. So you don't need to rely on the value of the first element.
Or you close over a reference that is available only to your functions and use this as a marker because you're guaranteed that nothing will use this address because only you can see it. Any reference?
Yeah, any reference. Basically, yeah, you can save some memory. Just a reference to the.
So no, what I was going to say is that there is this module called ListGen, but it's super crazy. So if you ever want to look at that, I don't know. It's but yeah, they have actually generators and like a lot of cool stuff, but they also like abuse the language. I know completely, like they override file handles and.
I wasn't able to sneak an example into my slides that actually wrote at work with iterators, more sophisticated, but I'll try to explain it. I had to read some results from a running height query. And then the data would come in a very uniform, not uniform format, so sometimes some values that I expect to be set are nulls, and nulls are strings, not actual undefs. And eventually I would need to show all this data into a MySQL table. So I had a function that abstracts the the code to run the hype query into just an iterator that returns the next row. And I had a function called pump over that takes an iterator and a destination, which was in some unified format, like some TBI sort of handle. And I could like give it a lot of iterators. The code was looking very succinct and easy to follow. I take a couple of different iterators and like point where the data should go. But that doesn't suffice because the data also need to be morphed somehow. And I started like writing little kind of iMap, iGrep iterators around those iterators that will take the data and say, in a function called make mutator, it would take a field at the specified index and replace the string null or empty string with an actual zero. That was like the particular case that I needed to default to zeros. And I would like, and then I had another function called mutate, something like that, that would take a list of mutators and apply them sequentially to every single row in the result set of hype. So that was looking like a little chain of code. But it looks very declarative. Like take data from here, modify those fields this way, and like take the data, feed it to the next one, etc. Maybe if I get around to extending this talk and giving it somewhere else, I will make sure to include this example. Or somebody can drop by and I will show the code. Good, I think that's time. Yeah.
Where did you get the cats?
There from the.
That's push. Yeah. That's on the. I will publish my slides. I will never. There is a copyright.
Yeah.
Pushing. It's pushing. Pushing. Nice one. Cool. Thank you.